Hello everyone, welcome back. So in this video, we are going to understand the Leetcode problem number 3093. It's the longest common suffix query. And this is ExpertFunda and you're watching on YouTube. Okay, so let's try to understand what the question is saying that and what is the meaning of this problem and how we can solve this type of problem. If in future we'll get this problem, then how we'll solve this problem. Okay, this is what we will do here. Okay, so let's try to understand first. The question says that we have a longest common suffix queries, right? And it's a very fantastic question, guys. I tried to create the video previously. I will delete that and I'll focus on here. Okay, I got some issue on the system, so I'll try to do it again here. Okay, the very first thing that you are given two arrays, guys. One, the container, word container we have, and the word query. So what word query is there? Like each queries we have given, you have to apply on the given words, right? For this you will apply on all of these three. Then for this you will apply again on these three. Then for this you will apply on this, right? How will you apply? What will happen? That we'll talk about more here. Okay, some important concepts we have that we will understand here. Okay, basically you will check this suffix cd in here, here and here. So you will get that everybody has a cd in common. Then you will check with the next query, right? So let's suppose for the in this case everyone has the same suffix, right? Then you will check with the concept. So some concepts are there that we'll talk about more. Then what you will do if the we have the common for everyone, if multiples are coming, and then how will you choose that which one you will use and which one you will not use, right? That we will understand. Okay, so these are the concepts we have that we will talk about. Okay, if you want, you can pause it and you can go through that, but I want you to understand from the very basics, so we should go with one by one. Okay, let's talk about the very first thing. What we have is what's the basics that we should understand, right, before solving this problem. So we should be very strong, or at least we should know the foundational topics. Let's suppose the string basics that you should know. Then a student should understand the very, he should be comfortable with string, reversing the string and iterating character. So this is mandatory. Apart from that, and the substring, right, intuition, this should understand. And the most important is here is prefix vs suffix. Means what is the prefix? Prefix is, like, let's suppose we have a coding in this. What is prefix in here? Prefix is cod. Why? Because in coding this word is cod is called prefix. But if you talk about in coding what is suffix, means ing is a code, is a suffix. So if this is prefix, so this is become suffix, right? Now think, so this problem that we are seeing, that this problem becomes easy after realizing what? Realizing this part. If means the suffix matching is equal to the prefix matching after reversing. Basically this is a trick, guys, with that who knows DSA, right, who has expertise, right, he understand that if we want to find let's suppose suffix matching, right, we just do the prefix matching after reversal, right? If you do the reversing of the given string and then you will find the prefix matching, that is nothing but the prefix matching. And this is the heart of the problem, guys. The problem that it says that suffix queries, right, common longest suffix queries that we have to find. So we can say that prefix matching after reversing, we can say that. Okay, it is based on that problem. Let's try to understand further what you should understand. It is very important to understand this part, guys. Okay, sorry, what happened, guys? Okay, so you should start with the tries, right? What is try? This is primarily a try problem, right? And we should know the try node structure, children array map, insertion and reversal. If not, it's fine, don't worry. Okay, but you should know at least before solving the problem. I'll discuss these things in our video. Okay, if I will not cover anything, you can let me know in the comment section. I will create there. Let's understand the basic try understanding. You should understand what is the basics try, right? So let's suppose three words we have. Sorry, guys, three words we have: cat, car and can. So these three words we have: cat, car, and can. Okay. In all these, CA is a common. And what is not common? T, R, N. So what you will do that, you know that C and A is common. So you will take root as a C, not before that root will be something else. So let's suppose that is null. But after that you will take C, then A, and these are not common. So you will make the branch of A, because after CA you can use T, R, or N to make these independent words, right? So without try knowledge, the problem feels overwhelming. So you should understand the tries also. Okay. Let's talk about the prefix matching problem. Okay. So as a teacher, what should I say? We should always solve the problem, the longest common prefix, and then search suggestion system that Google has already asked, then the implement tries, and the word dictionary. So these problem you should know very well, then you should go with this problem, right? Because this builds the mindset that we need here. Okay. So the prefix matching problem, if you are, if you have not solved this problem, let me know in the comment section so I can create a series for this, and we'll work on that. Okay. We'll do preparation there. We'll create a video for you and you will do the preparation. Either you can work on this, both is fine, right? Or keep a note of these three in somewhere so you can cover later. Okay. Coming back to the steps, then you should understand the greedy try breaking logic. What is the try breaking logic, guy? This is a try breaking logic because the problem has conditions. What are the conditions we have given? Is the longest suffix, shortest word, and the smallest index. These things you have to choose. So if you find the common suffix, right? Let's suppose the longest common suffix you will find. So you will find the longest suffix. Let's suppose if you have multiple suffix, right? Means different we have, let's suppose 3 length, 4 length, and let's suppose 4 length we have, right? Means 3 words we have, and we found that there is a different longest common suffix we found, right? Means you have to use the longest one. Let's suppose that there is not longest one because these are different, then you will use the shortest one. The shortest word, let's suppose, is multiple times we have, right? Means you will use the index wise. Let's suppose 0, 1, 2, and 3, these are the words, and at index 1 you found the smallest index, because index 1 and index 3 both having the same and a smallest shortest word, we can say that, but we can use the smallest index because this is the problem saying, right? The problem says. So here you should understand the greedy tie breaking logic, what we have, what the question saying here. Okay. So we should know how to maintain best candidate so far, and that's why every tie node stores the best index according to the rule. This is very good for interview, guys. So you should understand how you will build the greedy things, greedy logic, you can say, in the interview row. Okay. Let's go ahead. Then you should also understand, guys, the time complexity thing, right? So how will you understand the time complexity and how will you increase your thinking? The very first thing is the brute force solution is, for every query you have to compare every words, because if you do for every queries, let's suppose queries, many queries are there in the thousands, in the lakhs we have, right? And the words is also more, right? So what you will happen, if you will try for every query, you have to compare every words, and that will become very slow, guys. So we should already understand that why the nested comparison becomes expensive, how pre-processing helps, and why the try gives you the linear performance. So we should understand why we are going to use the try, right? Then we can use this. And the most important thing now we have is traversal. Traversal is a, like, let's suppose you do the traversal transformation, right? And then you will find the suffix. Let's suppose basically we want the suffix. If you'll do the reverse, you will get the prefix, right? So this appears in the suffix try, palindrome problem, rolling hash, and the KMP variations. If you are my student, you already know about these things. Okay. Otherwise, if you don't know, let me know. I'll create the videos on this. Okay. So this is the trick where we do the reversal thing. Basically, in the suffix, you will do the given thing. You will first given words or string will first reverse this, and if you reverse this string, right, basically that is becomes the prefix. Okay, so basically you will do apply this suffix. You will reverse. You will get the prefix. The reversal trick you should understand. Now let's talk about the ideal prerequisites problem. What should you do? The basically string, then prefix, problem, then try basics. Then you should understand the try optimization and the suffix transformation tricks. Then you should apply this problem. So it is very tricky problem, guys. Okay, so we should solve this problem, right? Then these are the questions. First you try these easy problems, then you try this medium problem, and then this hard problem. Still you have a doubt, let me know. I'll create the videos. Don't worry. You can keep this problem as a notes, right? You can work on later. Don't need to do work today only, okay? So we already understood what the question is saying that. If you not, you pause it and try to understand. We'll go through this example, don't worry, okay? Now we are coming back to the problem. The very first thing what we are given, we have given the words container and the words query. So word container is a list of candidate words, and the query we have is a list of query words. So here for every words, we have to return the index of the word in the words container that has the longest common suffix with the query word. Okay, so there is a type breaking rule where we have to prefer the word with the longest common prefix, and if multiple words have the same suffix length, then you have to choose the smallest length. If if still you are finding the smallest length, we have multiple, then you have to use the smallest index one. Okay, so these are the type breaking rule that you should understand. Basically, why we should not use the brute force, because the official constraint that allowed is 10 to the power 4 container words and 10 to the power 4 words we have, right? With the total container and query length up to, if you'll multiply 10 to 5 into 10 to the power 5 happens. So comparing every query with every container become very slow. So we should not use this approach. We should use the better approach. Now let's come back to the example so you will understand. So we have given the words container, then we have the words query we have given. Okay, guys. So let's suppose we'll go for the very first query, then we'll go for others. The very first query is query CD. So if you see ABCD, CD share the suffix CD, we can say, and you will see that the length is 2. Again, BCD, CD, they have the same thing, right? So in all of these cases, right, ABCD, BCD, XBCD, right, all of containing the same CD contains, and its length is 2, means all of having the same suffix CD and having the same length. Now we have to apply the tie break, right? How will the tie breaker will apply? Very first is the index 0, 1 and 2. So 2. So if you see here, right, for this the length is 2, 4. For this the length is 3. For this the length is 4, right? And so we have chosen the shortest length. So the answer is 1. Let's move ahead. Let's go with the query 2, right? And if you see the query 2, if you'll apply on these container list for all these 3 cases, you will see that, okay, I forget to write here, okay, BCD, all of these having the same length, okay, and all 3 have the same longest suffix BCD. Now you have to apply the type breaking where we have to use, okay, so here you will use the shortest again, because having the same length, right, we can say that you will use the smallest one. So we'll go with all, because since all are equally, so we'll choose the shortest word BCD, which is at index here, correct? Now let's move to the next query that we have is the last one is XYZ. For the XYZ, nothing is common, means everyone having common is null, right? Means there is no character suffix matches and any container word, so that the common suffix become empty. So every word share the same suffix, right? So we'll choose shortest word And again we'll find the shortest word is BCD, because here null common, here null common, here null common, but shortest is what? This one. So we'll use this one. So we'll index one we'll choose again. So that is why if you see in all these queries things, we got the index one only, and so we'll got the answer. Okay. Now talk about the core idea, guys. It's very important. We need to answer the query. So for every query string, we have to find the word in the words query which having the longest common suffix as a uh, value, right? So we have to find the word, right, having the longest common suffix. Let's suppose if multiple exist longest common suffix, right, multiple having, right, so you will choose the shortest word. Let's suppose if you find a multiple shortest word, means the ties again happen, means you will choose the smallest index. This is the core idea. Now let's talk about, if you're not understood, you pause it here and go through. Okay. Now let's talk about the best approach, the reverse tie that we were talking about. Basically, the suffix problem becomes prefix problem if we reverse the string. Means if given string is this, if we'll reverse this, right? So basically, common suffix is common prefix after reversal, right? So we reverse all the container words, then insert into the tie, then reverse each query, and then we'll reverse try to find the longest match. And so the important observation is at every tie node, try node, right? We store the index of the best candidate words. If not, then we know that there is two condition will be there, either a smallest length or either a smallest index will be there, right? So that we know already. So the try on the reverse, right, the reverse string, the try on the reverse string is a pattern, guys. It is very important to understand before going with the anything, right? See, this is a try and the prefix problem, we can also say, but we have the only one twist we have here, right? The longest common suffix becomes the longest common prefix if we read the string backward, right? Means for example, if we'll take ABCD word, right, if we'll reverse the direction become DCBA, correct? So if two words share suffix BCD, then their reverse forms share the C DCB, right? So if instead of building a suffix specific structure, we will build the normal try with inserting everything from right to left. So this is the standard efficient approach to solve this problem. Okay, you pause this and go through. Let's talk about why the try works here, right? The very first thing that each try node represent one suffix, correct? So if we'll take the word container, so very first we'll insert the word from left to right. How will you write that? You, like this. Means we have ABCD, we have means D to C, right? Basically ABCD will represent, you will represent like this, again like this, you will represent all of this. If you see what is the common is here, this part is common, guys, right? D, C and B, if you see it is common, correct? And A and X is not common, right? So very first thing that we know in each of these, right, what is the common, overall common, if you'll find all of these. So at index one, if you'll talk about the very first one, right, for index one, right, the word we have is BCD, we are talking about here, okay? And here for empty string, suffix will take the root first, okay? Now we'll go with the common one. The very first common is what? Here, D. So D is common. The very first common is D. So we'll put the here. Then for the best for the suffix, we'll use the CD. Then you will use the C here. Very first, if you see here, you can take like this also. All are common, right? You will use. Then another common is this. So we'll use the next one. So we'll use the B also. Now these are not common. So you'll use here and here. Basically, you understand what I'm trying to say, guys, right? These are the very important thing that you should understand. So here, from here to here, it become the longest common prefix, guys. Okay. B, C, D. You have to go with the reverse one, right? Like this. So if you do the reverse going, right, you can build any of this string. Either you are building this one, A, B, C, D. So you'll say A, B, C, D. If you're going with a B, C, D, you have to go from here. If you're creating X, Y, Z, so you have to go from here to here, like this, right? Like that, you have to keep going and you have to find for each string if you want, right? Like this. That is why it works, right? You can create any of these. Okay, you pause this and go through. The most important part here is the algorithm. So there is two part will be there, the build phase and another will be the query phase. Okay guys, so in both ways, right, we need to create the algorithms, and for that you have to create the functions also. Basically we need to we need to do that, right? Otherwise it will not work. Okay, so basically the build phase we have, like for every word from the container, right, what you need to do, we'll start at the root, then you will update the root with the word, because the root represent the empty suffix that we have already seen. Then we'll traverse the word from right to left, that we know that we'll start from right and then we'll go to the left, basically from like this. Sorry, okay, like this. Then you will create the try node as needed, and at every node you will update the best candidate, and then a smaller words means that will win, if not means who will win, the smaller index will win. Okay, either a smaller word will win or a smaller index will win, that we know already. Okay, so this is done. Then we have the query phase where we start at the root, right, but we have to traverse the query from right to left will go, right, and we'll check. Let's suppose we have a b c d, right, means from the root, if you want to traverse, you have to go from where you have seen that d was there, then we saw that c was there, then we saw that what was there, d c b was there, right, and then we saw that a, right, and another was a x. So if you want to start, you have to go from here, then here, then here, and then here, right, means right to left you have to go. Okay, like this. Basically we'll talk about like this one. Okay, then we'll keep going going with the, we'll keep going with the try has the next character. If we have the next character, we'll go with it like that we have seen, right, next character. Once traversal stops means the current node represent the longest prefix match, means let's talk about this one. Okay, basically you will start from the d, because a b c d we have given, so you will start with the d, so you will go d, then a, then you will go with the a, right guys, sorry, then you will go with this one like this. So this will not match, so this part become the longest one. Okay, and then you will return this index. Okay, current node dot best index, you will return it. So basically if you suppose, let's suppose we'll take this one, so we know that very first we'll reverse this thing, right, then you will take a query. Okay, query, if you'll reverse this, what will happen, it become dc, right, from the dc very first what you will traverse, d, right, so you will just traverse the d, then you will traverse what, c, because next but we have c, so you will traverse c like this. If we have uh, bcd, right, means very first you will reverse it to dcb, then you will come till here like this. If we have other characters, right, like that you will go. I hope you understand, right? I'm repeating the same thing again. So the very first what you should do is you will create the node, right, array. You will take the best length and the best index. Then there will be the starting indices, guys, where you will first build the reverse try from the container, and then you will do the query. So you have to create this insert to build that, and to query you have to create this function. Okay, and the query will return some index, so you will to keep adding over the integer value of the array. Okay, you have to keep the each element you will store. So basically you will create the array like this for inserting the value, and yeah, and into inserting the value, right, you need to create the update best. We have to update the best again, right, means let's suppose you start with the d, then you go to the c, then you go to the b, right, but here we have two things, a and x, right, so basically you come first for this one, right, so you will get the best length. For now let's suppose is this one, but next time when you go you will get here, so best length become this one, and again you will go with this one, so best length become like this. You have to update this again. Okay, so this is the function we have, so each time we will update here, guys. Sorry, I am going little faster, right? Then let's come back to the query, right, you know how to do the query. So basically you will pass the root and this query. So over this query, you will call this query, right, and you will get this value. Okay, I'll put the code, you go through and you will find the best index again. So that's what we have in this video, guys. I'll put the code in the comment box so you can do some hands-on, you do the debugging. Let me know in the comment section if you have any doubt, and I hope you will like this video. Any of this basic fundamental thing, if you don't know, let me know in the comment section so I can create in the channel, right? I'll create a playlist with this video as a try, and we can go from there. So, or you can keep a notes somewhere, you can create by your own. That's also fine. Thank you so much. I'll see you in the next one.